All right, guys, so this morning, it's going to be a short little lesson here. Today's going to be not too bad of a day. Um, what we're going to look at this morning is what we call the limits of indeterminate forms, and it's what ends up happening when we go to evaluate a limit, like what we were doing in yesterday or the day before, right? When we go to evaluate a limit and we get 0 over 0, okay, that's what we call the indeterminate form. Okay, and all it means is the way that the function is written, or the limit, is in a way such that when you plug in whatever limit you're looking for, right, as x approaches a particular value, you end up getting 0 over 0. And that's just, these are interesting questions from the standpoint of the way that they are written. They end up giving you 0 over 0. But as we've seen with rational variable expressions in the past, we're able to rewrite those things using some of the tools that you've learned in the past. So that's what we're going to do today, right? And if you recall, factoring, like different kinds of factoring, right? So right back to grade 10, we've got something, a difference of squares, right? Difference of squares states that if you have the square of this and the square of that, then we can dissect that down to be, if I were to factor this, a minus b times a plus b. Okay, and the opposite signs create a middle term that has a 0 on it. Okay, and that's why this is called difference of squares, but you have to have the opposite signs, right? If you guys recall. Now, difference of cubes. Well, we can take a minus b out, and then we can write what's left after. Well, it's going to be a squared plus ab plus b squared. Okay, and the last one was sum of cubes, right? Well, we could take the ab out again and then write what's left. Well, we're going to have an a squared minus ab plus b squared. So these would have been two that you've learned in grade 12 functions. And obviously this would have been learned in grade 10, applied in grade 11 when you did the rational variable expression unit. Okay, so what's this mean? Well, let's take a look. We've only got 5 examples here. Some of these, the last two might take a little bit more space, but you'll get the idea quite quickly, right? Like if I were to, let's say, just evaluate this limit right off the bat, right? And I plug the negative 5 in. Well, negative 5 squared is going to be 25. Minus 25, well, that's going to be 0 over negative 5 plus, that's 0 over 0. Okay, what am I going to do with that? I can't do anything with it. I can't evaluate the limit of this function as it's written right now. But I do see that the top is a difference of squares. So I could factor the top, and then we're going to see what happens, right? So we're just going to rewrite the limit as x approaches negative 5. We can rewrite the numerator as being x minus 5, x plus 5, all divided by x plus 5. All right, and what we see happen is we can cancel these out. And so now we can evaluate the limit as x approaches negative 5. Well, we can just let me just finish writing, of that. And so we're going to see that the limit as x approaches negative 5 is negative 10. Okay. Now we can do the exact same thing here. We're going to see that when I plug in, or I try to see what happens to this function as I evaluate or as x approaches negative 3, we're going to see the same thing, 0 over 0 here. Okay. And so again, we're going to have to simplify the expression that we see. Okay, so the very first thing that I would say we could do, even like as it's sitting currently, like this isn't necessarily, it doesn't look like a sum of cubes yet. Okay, so I'm going to do one thing and change it, right? I'm going to say, okay, well, I can go x cubed plus 3 cubed over 3x plus 9, right? Because 3 cubed is 27. And then from there, we can apply our sum of cubes rule, right? So we can say, okay, well, the limit of x approaches negative 3. What is this? Well, we can remove the x plus 3 from the top, right? And then we write what's left. We're going to see that there's an x squared minus 3x plus 9 over, now there's something else we could do in the denominator as well. Looks like there's a common factor that could be removed between those two terms, so let's do that. We remove a 3, and then we're going to get x plus 3, and look at that. Okay. Now we have this nice function that we can evaluate the limit at, right? Because we know we're not going to get a 0 in the denominator because there's nowhere to put an x value anymore, right? So we're on the right track, right? And so if I was to evaluate, here I'll rewrite it just to clean it up, x squared minus 3x plus 9 divided by 3. If I was, oops, make sure you write the limit. If I was to evaluate this, I would see that I'd get 9 plus 9 plus 9 over 3. 9 would be my limit. Okay. So far so good, I think. Okay. This one, a little trickier. But again, if you were to evaluate this at x approaches 0, you'd get 0 over 0, right? Because anything to the exponent of 0 would be 1. 1 minus 1, 1 minus 1. You get the 0 over 0 again. Okay, and so this is how you identify a limit of indeterminate forms, right? Or of an indeterminate form, is when you get the 0 over 0. Okay, and then you have to do some simplification in order to actually see what's going on. Okay, so I'm going to rewrite this function. It's going to be the limit as x approaches 0, but I'm going to remove in the numerator, I'm going to remove a factor of what's common between both of those pieces of 3x. Okay, I could remove a 3x, no problem. And we're going to see that I get 3 to the power of x, not 3x, 3 to the power of x, and then I get 3 to the power of x minus 1 over 1 minus 3 to the power of x. Okay. Now, I'm even going to do one other thing here. I'm just going to, because I know what to do, but it sometimes gets confusing with the negative sign. So I'm just going to flip these. I'm going to flip the order of these. I'm going to write negative 3x plus 1 here. Okay, now, let's say, just to, because I can see this sitting here, and I'm like, okay, well, these look very similar, but they're not quite the same. So why don't I remove the negative, right, and see what happens? Well, I get the limit as x approaches 0, 3x. Keep wanting to write 3x. 3 to the exponent of x minus 1 over negative 3 to the x minus 1. Okay, and now we can see that these cancel. What are we left with? We're going to evaluate the limit as x approaches 0 of 3 to the power of x over negative 1. Okay, and then we actually see that the limit is negative 1 when I evaluate the limit algebraically as x approaches 0. Okay, now here come the little bit more of the challenging two. I would say even D a little bit more challenging than E. Not for any reason in particular, but just the fact that there's just more work. It's all tools that I think you guys have. Okay, so this looks like a busy question, and it is. Okay, I would say from right off the bat, I would simplify what you see in the numerator. Okay, no matter what happens here, like if you were to go to evaluate this limit, you're going to get 0 over 0 again. Okay, so we know it's going to be fine. So let's evaluate this, the limit as x approaches. We're just going to have to simplify a little bit. 3 over 2. Okay, and so let's rewrite the numerator as being 2x, right? And I can cube 2x, squared cubed, and then minus 3 cubed, right? That looks like a difference of cubes to me, right? And then in the denominator, it looks like I could remove maybe a, oh, what are we gonna have to do here? Oh, I see. We're gonna have to use our long division to do this, okay? And I'm going to divide, because this is what it's telling me to do, that's why. Okay, I'm going to divide 2x minus 3 into the denominator. Okay, so I'm going to go 2x minus 3. I was just a little confused. Okay, I'm going to divide that into 2x cubed. Oh, I'm going to need to leave myself some space on top too. 2x cubed minus 9x squared plus x plus 12. Okay, I'm going to move that down so I have some room here. Okay, and so in typical long division fashion, you know, we're going to divide the 2x into there and see what happens. Okay, well, I get a 2x squared. Oh, sorry, a 1x, just an x squared. Sorry. An x squared, and then I multiply down, right, onto both of these two things, and I get minus 2x cubed minus 3x squared. Okay, and then I'm going to see, okay, well, a negative 9 minus negative 3 is going to be negative 6x squared, and I'm going to bring the x down, so plus x, and then I divide in again, and so I see a minus 3x. Do the same thing, we're going to get minus negative 6x squared plus 9x, right? Then I'm going to do, I now get 0x squared here, and then minus 8x, bring the 12 down, and do this again. I divide into there, and I get minus 4. Okay, and you'll see minus negative 8x plus 12. Okay, so these actually get zero remainder here, which is nice. Now, you now have what the result is, right? You can rewrite the denominator, because ultimately what you wanted to do was get a 2x minus 3 in the denominator, right? And so we can rewrite that now, right? We could say, okay, well, let me just erase this here. We can rewrite the denominator as being 2x. Oops. 2x minus 3 multiplied by x squared minus 3x minus 4. Okay, and then we could say, well, the numerator, we'll have another look at the numerator now. That's a difference of cubes. We've strategically written that in a way that it's a difference of cubes. Okay, and we're going to see that if I were to go limit, right, we're going to see 2x minus 3. I can remove that. And what's left for a difference of cubes? Well, you're going to see that that is 2x squared plus 2x times 3 plus 3 squared. I'm going to move this over. Just run out of room. Okay, and that's all still divided by the 2x minus 3 over x squared minus 3x minus 4. Okay, now this cancels with this. And what are you left with in the numerator? You're left with 2x squared. Sorry, not 2x squared, 4x squared. 4x squared plus 6x plus 9 over x squared minus 3x minus 4. Okay, now we can try and evaluate this limit now, and we can see that I'm going to go 4 times 9 over 4, right? If I were to evaluate this, 3 over 2 squared would be 9 over 4. That's where that would come from, okay? And so then we can go plus 6 times 3 over 2 plus 9 over, same thing in the bottom, 9 over 4 minus would be 9 over 2 minus 4. Okay, and then the numerator, you'd see like the 4 would cancel with the 4, you'd be left with 9 there. 6, this would be a 3 now. 3 times 3 would be 9, right? Plus 9, so you'd have 9 plus 9 plus 9 in the numerator, so 27, right? And then the denominator, you'd have to get a common denominator between all of these three things, three terms. You'd see that that would be negative 25 over 4, the answer there. Okay, and then you'd bring it up and multiply by the reciprocal, so you'd have 27 multiplied by 4 over 25. Okay, it's still negative, sorry, there you go. And then the answer would be negative 108 over 25. That's the limit. So that's kind of a mean question from the standpoint of like, you got, yes, what I mean, there's lots of work there. You got to use the long division to figure out what the factors are in the denominator. But then also, I didn't even give you a nice limit to evaluate, which kind of sucks. Okay, the last one, a nice way to finish off the lesson here, just a little bit easier. I see if I were to directly input the limit as x approaches 0 there, I'm going to get 1 minus 1 over 0, which is 0 over 0 again. Okay, so this is, again, we can see this is an indeterminate form. So we're going to have to do some simplification. The only really simplification that I think you guys can see with this question is something like rationalization with the radicals, right? So we're gonna rationalize the numerator using the two terms, right? I've got two terms there, so I'm going to multiply by the conjugate of the numerator. So I'm going to go 1 plus 1 square root of 1 plus 3x over 1 plus the square root of 1 plus 3x, okay? And then you're going to see that we're going to get the limit as x approaches 0 of 1 minus 1 plus, we're going to be careful here, 1 minus 1 plus 3x. I should just leave that in brackets. Okay. And then that needs to be divided by x times 1 plus square root of 3. Sorry, 1 plus 3x, sorry. Okay, so if I were to distribute this negative into the bracket in the numerator, you see the limit as x approaches 0 of 1 minus 1 minus 3x over x times 1 plus the square root of 1 plus 3x. Okay, the 1's create a 0 pair, they're going to cancel out. And then we're going to see the limit as x approaches 0 of negative 3x over x. Okay, be more defined with the bracket here. X's cancel with one another. You're left with the limit as x approaches 0 of negative 3 over 1 plus the square root of 1 plus 3x. Okay. Now, if you actually evaluate that limit, you're going to see that you get negative 3 by 2. That's it, guys. Okay, a little bit more challenging. Not like they're just limits, but they're a special kind of limit, right? They're a special kind of limit in the sense that, like, initially they give the impression that they don't exist, or like there's something wrong, right? Because you're getting 0/0, but that's a clue to you to simplify the expression that's on the page so that you can actually get a numerical value for the limit as x approaches whatever value they're interested in. Okay, so that's the limit. That's limits of indeterminate forms. I'm not going to explicitly say on a test or anything like that this is an indeterminate form. You would just go through the normal process of evaluating a limit, and then you would see that it's 0/0, and then you could do the simplification work. Okay, so that's I don't know. It's kind of a nice lesson. Okay, it pulls upon some things that you've done in the past and combines it with some stuff that you've learned in this course so far. Okay, so you guys let me know if you have any questions. I'll be available in office hours. Okay.